Hey there, welcome back to the channel. So, in the previous video, I wrote like unsafe code. As everybody writes in C, I wrote like unsafe code, and I also like didn't cover a feature completely. Like there is some things to add to it. The splitting part of the like free block. So that's what we will be working on, and yeah, let's get started. So, okay, we go on our desktop, RLF, it's in allocator.c. Is this 18? Yeah, okay. So, yeah, that here, we were over here. So this is not covered completely. So we will be doing this. We will also be covering the unsafe code later on. But the first thing that I have to do is like you can see like okay. Let me show you an example. So the thing is that I have noticed like most of the people that come in my video are mostly like first timers. So I would like to explain what I'm going to do. So wait a minute. So so I have my diagram ready. So let's say if anybody doesn't know what is a free list is kind of a linked list that has like free blocks. So these are free blocks. These are basically pointers. So these are the free blocks. You can say these are the free blocks, and these are pointers that are present inside it. So what happens is that let's say my process wants 100 bytes of space. So what it will do, this is the starting of the free list. Let's call it free pointer. So if my process wants 100 blocks, 100 bytes, 100 bytes, so what it will do is that it will traverse this linked list to find, you can say, the appropriate size block. So we are not using like the best fit algorithm. We are using the first fit algorithm. So we are just going to return the first block that we find is of appropriate size. So we are not going to go for like the most the most perfect block. We're just implementing the first fit algorithm because later on we will be implementing like more complex algorithms. So like uh, there's a bind algorithm like bind free list. So that's what we'll be implementing, but later on. So what happens is that we will traverse this free list. So we'll go on this block. We'll say, do you have 100 bytes? It will say no. Then the pointer this pointer points to the next free block. We'll go over here. Do you have 100 bytes of free space? It says no. It will go over here. Do you have 100 bytes free space? Yep, he does. So now what do we have to do? So this is a free list. So in this free list, there are free blocks. So they point. So this the node is compulsorily like you can say a free block. So now that we have found a block which is free that has an appropriate space of 100 bytes, this block cannot be present in the free list anymore because we will be allocating the space inside it, right? So what we have to do is that we have to forget this and we have to make the previous block point to the next free block, thereby skipping this block completely. So that's what we have to do. That's what I missed yesterday. Like not missed, but I like decided that I will implement that feature later on. So that's what we are going to do. And yep, that is it. There are other things too that inside this block, like we have to split, uh, we have to perform splitting and check if the remaining free space is like you could say of appropriate size, check for internal fragmentation and all. That I've covered in the previous videos, and we will take a look at it afterwards, like a few you can say for a few time, not few time, but for a small duration, but it won't be of major focus in this video. 1199, and you have my screen capture. So let's get started. So now that you know, um, you can say how free list works, let's get started. Let's implement the feature. I will show you the particular code that I'm talking about. So 1199, the screen capture is working. Okay, let's go. So here is the iterate free list. It should be traverse free list now that I'm thinking of it, because we are not iterating it technically. But okay, I'll change it up later on. Uh, okay. So what it does over here, I'll explain the code. Copy free pointer. We create a copy of the free pointer. Free pointer is the initial, like the starting node of the free block. So like you're getting me. So uh, this is okay. Let's skip it. So uh, this is the pointer to the first block inside the free list. So we create a copy of it, and then we are going to traverse this free list until our copy free pointer is null. That basically means is that until we reach the end of the linked list. So we get the size from the free whichever block we land on. So our first block, second block, third block, we'll get the size of it. We will size pointer of it. We'll find the actual size from it by dereferencing the pointer, dereferencing the pointer, and then we'll. This is a condition. You might not understand what is happening over here, but it's fine. Uh, just think of it like it's finding the appropriate block of the like vertical size. So what we have to perform over here is that I didn't add like the as I explained the skipping the block that has been allocated. So this is else. Well, I didn't have to like add else over here because here we are basically returning. So this is not necessary over here. So I can basically just do this and it's fine. So sorry. So what I need to do is I need to perform some changes inside this if condition. So what this if condition does, it will this if condition is satisfied only when we find the block of appropriate size. So what I need to do first, I need to add you can say a previous block. So previous block, let's say previous block points to null. So when we are at the first block, our previous block will definitely print to null, right? So uh, points to previous block compared to the compared to the current uh, current position, you can say, right? So this is what it points to, and now we have to uh, perform one more change, which is we have to add an if condition over here. Can you guess why? Sometimes what will so if we have to skip it, so we can skip the block only when like it's so the skipping part, like the changing the pointer from skipping like the second block. So block will point to the third block. We can only do that when a block is in the middle, right? We cannot do it when the block is in the first. So that's what we have to add a if condition. Although I've seen a video of like Linus Torvalds, uh, which he talks about like iterating, like writing better code. I will take a look at it. I will optimize like not optimize, but like write better code. But for now, I'm just going to go with what comes in my mind first. So let's just go ahead. So for this, I think we it will be better if we calculate this part above. So I'll yank it and I will paste it over here. I won't be needing this for now. Yeah, this is this is correct in its position. So I'll write what is opening over here. So moving copy the pointer to the next block. That's fine. And the previous block becomes the copy previous. So not over here, here. So previous block becomes the, you can say, previous block becomes the current copy pointer. Is changed to current block. Oh, sorry. Previous block value is changed to current block. Now this is correct. And here I will write, you can say, next block is taken as, well, this is not technically like the next block. We just needed something to store the copy free pointer in a like void pointer to pointer array. So not technically the next block, but helps in saving copy free pointer as a different form, in a different form. So so it is easier to dereference it later on. Later on. Yep, perfect. So we were over here. So our previous block becomes the current copy free pointer, current block, and and the block becomes the next block. Yeah, that is correct. So now inside the if condition, what we have to add is if. So if we find the appropriate block, now we have to check. So if you can say, let me take a look at the board. So if I'm over here, so if I found out that my previous block is null, so this if condition basically means we have found the appropriate block. It's no longer like we are iterating. We are 100% sure that we have found the appropriate block. So that's what we have to do. So if we find the appropriate block, and now we have to add a if condition. So if our you can say previous block is equal to null, if our previous block is basically like like when we were traversing the free list, we found the appropriate block in the first place itself. Like the first block that we landed on was the appropriate block. Boom. So we don't have to do like pointer pointer or karate or something. Uh, Pointer moves. Shuck, shuck. Instead we'll just move the copy free pointer. So like instead we will just move the free pointer to the next block, you can say. So that's what we'll do. So here I will change the free pointer, you can say. So free pointer is equal to next block. Well, technically dereference next block. Okay. So that's what we are doing here. We changed copy free pointer, which was a current pointer, to the dereference next block. So the pointer moved to the next block. That's what it did. Free pointer is now pointing to the next block. So that's what I will write over here. So if previous, if we find appropriate block at the very first position, we just move the free pointer to the next block. So now free list starts from second block instead of first block. That's it. It was that simple. And here I'll write an else condition. So if it isn't the, you can say, if it isn't the next, like if it isn't the first block, then what are we supposed to do? Well, we have to make it so that the previous block points to, you can say, the next block, right? Dereference next block technically. So previous block. So previous block is a pointer to the previous block has a value. So here we will have previous block is equal to dereference next block. That is it. Is it though? So previous block points to so previous block becomes a copy free pointer. So previous block which was pointing to copy free pointer previously. So I'm over here. It is now pointing to the dereference next pointer. So this address 789. Yep, that seems correct, I guess. You can say. Like I can that this seems correct, right? Wait, how many minutes are we in? 16 minutes. That's great. Um, and we have made like not that big of changes. Let me just give me a minute. What is happening? What is happening in Shibuya? Okay, so we changed the value of the previous block. So previous block was pointing to, you can say, the value of previous block is the address of the current free block, and now we have changed it to the value of inside it. So instead of 123, so I'm thinking that that's what we have done over here. So let's say at this particular at this particular point, let me give it a full screen. The thing is that I'm not able to explain though very clearly, so I have to rely on my whiteboard skills and my drawing skills. But I guess it's not a big deal because visualization is better than thinking in my brain, and it's better to think out loud, you know. Is it better though? I'm not sure. I just said it. But okay. So let's say I was present over here. Wait, there it is. Where is my duster? Wait. It was present over here. Where did it go? Okay. Found it. So let's say I'm at this position. So when I'm at this position, my previous block, sorry, my previous block has a value of 123. Sorry, my bad. It has a value of 456, right? So that's what the previous block is pointing to. Previous block here was null, and now it is 456, right? And here, so previous block is pointing to the, wait, you guys can't see it, and it's okay. Previous block has the value 4, 5, and 6, and now next block will technically dereferenced next block has the value 7, 8, 9. Well, not 7, 8, 9. Dereference next block. So sorry, next block. So it has a value 1011. So we say like the next point, next. So let's say my previous block is over here. My current block is over here. My dereference next block is over here. So 1011. That's what it is. So I will see like, wait, though, did I mess up? So my previous block is pointing to. I think I did mess up. Well, that's what. This is what you're. This is what like. You can say this is what. This is why you clicked on this video. I. This is what all my channel is about. It's just me trying to learn stuff and making mistakes on videos. And yeah, so my previous block is equal to the dereference value of the next block. Okay, but though previous block, this is the previous block's value, right? So I have to say, like, wait, this is okay, wait. So previous block, the value of previous block is now dereference next block. I think that's correct. Okay, okay. Let me just do this. But okay, okay. Uh, changing the, I can just say, skipping the allocated block, the appropriate, the chosen block, you can say, skipping the chosen block and making the previous block point to next block. And okay, so let's go. So here we are. So skipping the chosen block and making the previous block point to the next block. That is correct. And okay, so let me just think about it. So our previous block initially points to null. That is correct. And then our copy free pointer definitely points to 456 because it is at 123, right? Okay. Then null will then my previous block will point to 456. My current block will point to 789, and my next block, which I've taken using like which I've said like the next block is 789 itself, but treated as a pointer to a pointer. So by dereferencing we get 1011, and then if we get the 789, the address of 789, right? We don't get, we can say, we don't have the value of it. So I have to make it so like the previous block is a pointer to a pointer. So I have to make it so that the pointer is a pointer to a pointer, and we change the pointer and we change the value of the pointer to a pointer to the next block. So if I have to do this, this will just change the value. So I will say that the void will I will cast the previous block into this, and I will change the value, and then so I have to treat previous block as a pointer to a pointer. Is it recording? Yeah. Okay. Uh, okay. I'll add a flag over here. So I will write H. I will look at it afterwards. Like after my mind has cleared up and all. but I think this seems correct. So we are traversing. Yep. I think I need to like really work on like the validator file that we are given. I think once it's up and running, I can test a lot of my code because I can't do any kind of testing right now. I need to write some unit tests. Okay. So how much have we done? Get diff. Yeah, not much. Okay. So what 100. Wait. So it's 25 minutes in. That's fine. So okay, my mallet. Yeah, let's work on this one. So now that we have, so yeah, yeah. So this calculation. Okay, the actual block size, header, size pointer, space is equal to the actual block size. Mm, so size difference is equal to actual size minus current size. If size difference is greater than or equal to 24, if we find that it's greater, then we have to split it, right? Yep. And if it's smaller, then we'll just change the value of the sizes. That's it. Got it. Okay. So what change do we have to do over here? Why did I left this over here? Is it just for like calculation purposes? Wait, what was I thinking adding this over here? And why did I commit this? Split block pointer points to start of the new free block. Void split block is equal to void pointer to. Okay, okay. So if it's greater, then we have block space is equal to actual block size, which we find over here that we get from the free block. Actual block size, and then just give me a minute, just a minute. I'm back. Yep, back at it again. So let's go ahead. So we were over here, and our top charging is okay. It's at 71%. That's fine. Okay, so block space is the actual space. So yeah, yeah, block looks like size plus pointer plus space plus size. So the total space that can be utilized by a process is space plus pointer size. That's correct. Out of which a line size will be used. That's correct too. I think I should draw a diagram. Just give me a minute. I will draw a good diagram and I will show it to you guys. Uh, okay, so block. So you might be wondering how our actual space is like actual space that we get from the block and plus pointer size. Why are we saying like the total space that can be utilized is space plus pointer size? I'll explain you in a short amount of time. Like not short amount of time. Just give me a minute. So here we have size. Here we have size again. Here we have pointer. I think I should draw while I'm saying this because it's like probably pretty boring for you guys to like watch me doing nothing. So it's better if I directly draw in front of you. Wait. Yeah, okay. So this is what I'm cooking up. So so this is what our block looks like. Our block has two size values. This is the, let's say this is a, this is 100 bytes. So this is what it will have. It will have the 100 values stored inside it. It will, this will also have the size same value stored. You will ask like, okay, it's not visible. I guess 100, right? You must be asking like, why does these both values have 100? Why not just keep a single value? Uh, you have to watch previous videos for that. Uh, this is a pointer. So this is the free block. Since you can see it has a pointer, so this will point to the next free block. Hence, it has a pointer. Now you can say, can you think of it? If a block is allocated, why does it need a pointer? We don't need it, right? Like if it's an allocated block, there is no use to keeping this pointer. So thereby we can say the total space that can be utilized. So let me also show you another diagram. So what does, this is a free block, free, right? And uh, this is what an allocated block will look like. It has the same size value, and this will also have the size value, right? Can you change? Can you see a difference? It doesn't have the pointer. So the total, so if I have to convert this into an allocated block, so let's say a process, for example, let's say a process comes to me and asks for 100 bytes of memory. I can allocate this block, right? That's great. What if what if another request comes in of 105 bytes? Can I allocate this place, this block? What do you think? For 105, right? Can I do it? Well, if you think about it, we can, because we don't need this pointer, right? What is the use of it? So we can say the total utilizable space is 100 plus the pointer size, which is, you can say on 64-bit systems it's 108, right? 64-bit and divided by 8, so it's 8 bytes. So the total utilizable space is 108. So if a process comes in which has a request of 105 bytes, we can allocate this block to it. Thereby, we will just override the pointer value, whatever it has, because we don't care about it, right? There are other changes too inside the size, uh, but I will not be covering that. Okay, so that's it. So that's why we said like the total space. So this is the space that I've talked about. So space plus PTR size is the total utilizable space. And aligned size, the variable aligned size is basically like if the process asks for 5 bytes, we just make it aligned, like we will just make it a multiple of 8. So 5 becomes 8, 16 remains 16 because it's multiple of 8. Wait, you guys can't see it. So 5 becomes 8, uh, 16 remains 16 because it is a multiple of 8. 15 becomes 16, 30, we can say, let's say another example, let's say 9 also becomes 16, right? So that's what align size is. So that's why we are saying like the total, let me say, okay, I'll show you another example. So now that you know like what does how much total utilizable space we have. Now we'll show you how does the splitting work. Like in a brief, in a short way. So let's say a process comes in and asks for 50 bytes. No, let's say make it aligned. So let's make it eight. Let's make it 16 bytes itself, right? Okay, yeah, fine. So this has a total utilizable space of 108. A process comes in and asks for 16 bytes. That's cool. So sorry, our block now will look like this, where it has a size It has 16 bytes allocated. It has the size value again. And you didn't think, right? Uh, you didn't think like we would be allocating this entire space to the process, right? That's a very bad case of fragmentation. That's why we are like implementing splitting. So now this block is split into two parts. First, the request is met. This is the boundary. And now we will have another free block over here. This will be the size. This will be the pointer. And this will be the size again. And this will be the space. So that's what splitting does. So now that is what it is present inside the if condition. So when we say that, sorry, yeah, okay, OPS 1199. Come on, that's a sweet spot. Oh, I messed up. Oh, where is my 1199? Yeah, perfect. So screen capture is working. So okay, so block space. So this is a totally utilizable space. Is no, so block space basically means like the right part that you saw after like uh, the fancy line which will have size plus pointer plus space plus size again. So that is the block space. So now we have to split it again, like we have to allocate the size and pointer and size values again. So that's what we are doing. So split block will move the void pointer to the start of the free block. So we will take the freelist output. Sorry, we will move it by size, we'll move it by line size, and we'll move it by size again. Uh, Sorry if you're not getting it. Most I'm not sure if any one of you is still watching this video. If you're watching, thanks for being with me, bro. Like so, okay. Uh, if anybody is watching, for them I would like to explain. Thanks for watching. Oh, sorry. So when I say over here, over here, when I say split block, so when my pointer will point to, you can say, wait, I messed up. Wait, I really messed up. That is before I made the design change. I am a fool. I am a real big fool. Oh, why am I like this? So split block, yeah, okay. So split block, this is a pointer. Free list output basically means here, here we get the free list output, and we don't have to move by, uh, you can say the. Oh, I'm so blanking out right now. Okay, so free list output. Yeah, okay. So free list output. We should move by pointer size, then space plus size t size, right? Yeah, this should be pointer size of size t size, pointer size. So split block pointer points to the start of the new block because it is at pointer, pointer, space, size. Yep, perfect. So now the real block space is equal to block space that we have minus size t size minus size t size minus pointer size. That's correct. And header split block is equal to split block. Footer split block is equal to split block plus size t size plus pointer size plus real block space. That's correct. So this is correct. I don't think we have any changes over here. So here we have to change one thing, which is now we have to you can say. So split block, so split block. Yeah, let's do it. So we are over here. So let's make this change. So split block pointer. So I'll say void block. So split block pointer is equal to uh free list, not free list output, but split block itself. So we will cast the split block into char. So split block plus you can say size. We'll cast it into void pointer, not void pointer, but pointer to a pointer, because it is technically a pointer to a pointer. Or let's keep it void pointer to a pointer. So we are seeing that the pointer over here, the void over here, this is a pointer to a pointer. It's not void. It's definitely not a pointer to a pointer. It's just some space, and we have to do some changes in it. So this is just a simple void pointer. Yeah. So this is a void pointer. We cast it into void pointer again. Sorry. So split block, the size. We are at the pointer value, and now our free pointer. So now the split block, moving getting the pointer to the split block. You can say it's vague, I know, but it's fine. So now we'll cast so split block pointer, not yeah. Okay. So this is now the new free pointer, right? So split block pointer is now the new free pointer, and free pointer now is pointing to the address of the split block pointer. What? So split block pointer. The value of split block pointer is now supposed to be. This is just changing the pointers, right? It is not necessarily changing the value inside it. Okay. I think it's 43 minutes in. Uh, so split block pointer is free pointer. Mm, it let me. Okay. Let me think about it. Uh, 44 minutes in. We haven't done anything much. But okay, that's fine. So split block pointer is equal to free pointer. So split block is the free. So free pointer points to let's say this block. Now I have to make it so that free pointer points to this block. Right, it has the value of 123. Now to make it so that the 123. is present inside this split block. So split block should have, so I have to make it so like the void pointer to pointer, and I have to dereference it. So free, I will say like the free pointer, consider the free pointer as a pointer to a pointer, and then I will dereference it. So I will get the value of the block, the next block, like the address of it, and I will store it inside split block pointer. And, and then I will change the free pointer variable to make it so like it is now the free block pointer, right? This is supposed to be correct, right? Split block pointer has the value inside it as the address of the free pointer. And now this is split block. This doesn't seem correct. I'm not sure what I'm doing. I am not able to understand. Okay. That's why I was thinking like we need a way to test things. Like if we have a way to test things, it will be better. Okay, I will I will try to get like the validator.h function, like validator working. It's a file that we have to do some changes in. Okay, we definitely need a validator. We needed a validator like yesterday. Okay, so if you're allocating this, sorry. So header size pointer. Ah, let's cover this for now, right? So header size pointer is previous output minus pointer size, size t, this is fine. Like the size of the block size. Yeah, okay. Let's remove this. And now we will store getting the uh, pointer to footer. So size the pointer footer size pointer is equal to cast into size t pointer, which we will have using car pointer of free list output. We will only move ahead by we would only move ahead by let's say pointer size plus a line size. Yep. And then we are at the footer. We'll set the footer value. We are thinking only for the block. Hence only adding pointer size plus align size to the hence only moving ahead. ahead by pointer size plus element size, and not caring about the piece if present. Okay, so for the size pointer, we'll change size to, yeah, I guess this is it. So for the size pointer, it's put actual block size or n size. Yeah, I will remove this. This is correct. And we'll just increase it. Do fence plus equals. I think I need to do this. I know we don't need it probably, but it's just safer to do that, you know. I don't see any problem over anywhere. So size t pointer, changing this. The rest I think is fine. I'm just stuck on this part. How are we supposed to do stuff? I was also stuck over here. I was just stuck before. So yeah, I'm like right now I'm not sure about this one too. So like, I'm not sure about this, and now I'm not sure about this too. So yeah, 51 minutes in. I guess this is a good length for a video. Uh, and I guess this might be a good end. If someone is watching till the end, thanks for watching. Most probably no one is. But okay. So thanks for watching this video. I'm Aditya Pacharni, and I'm an engineer for fun. Bye.